Today we are going to solve Cambridge International A-Level Physics, okay, with the paper code 9702, paper 4, variant 1, May, June 2025, okay. And I will try to focus mainly on the concepts and the formula implementations of different questions understanding. Insert is given with you with these constant values and some formulas are given. Okay, before starting to the solution of this paper, I will simply request you kindly subscribe my channel and share the videos with your friends. And also, I will say here, if you find any error or your concept is not clear in any question part, kindly comment over there. And uh, why I request you to subscribe, because most latest paper solutions which you want can also comment over the videos. I will upload also with them. Thank you so much. Let's start with the paper over there. Question number 1 here, he is saying that define gravitational potential at a point. Gravitational potential at a point means gravitational potential, which means we will say here, just like a potential difference, I will say here that gravitational potential will be shown by the symbol phi over there, which means work done per unit mass over there is called gravitational potential, in which we can say, according to statement, work done per unit mass per unit mass is called gravitational potential. And if I want to take an object from infinity position inside the gravitational potential field around some planet over there, inside a required point over there, then the work will be done against the gradient over there. That is called gravitational potential. Then I will say that work done in bringing an object in moving a mass, work done in moving a mass from infinity to a required point over there. From infinity to a point, infinity to a point is called gravitational potential, because energy is done for per unit mass. So we will have to take it into account how to go with it. And here he is saying Mars is a planet considered to be an isolated uniform sphere of radius 3.4 multiplied 10 raised to power 6 over there, where I will say here that let's suppose this is the planet Mars, whose radius is given with the value. This is the radius of Mars over there, 3.4 multiplied 10 is power 6 meter. After that, he is saying a satellite of mass 122 kg, means it is small m, orbit around the Mars at a constant height 1.710 is to power 6. So I will say here that it is r plus h, means this r is being added by this value also above the surface of the planet. So it is only h, and I will have to say that it is the h over there. This is h, and the orbit, and the planet is orbiting in this orbit. After that, he is saying the height of the orbit is increased to this point. So now h plus h1, I can say another orbit is being added. And now the planet is shifted towards this another height, where he is saying that it is has attained is height h1, let's suppose here, which is being taken as 6.8 multiplied 10 raised to power 6 over there. In both of these cases, he is saying this increase gravitational potential energy of the satellite is being taken 5.1 multiplied 10 raised to power 8 joule. All right. Show that the mass of the Mars is this kg. All right, for this one, I will have to say, first of all, we should take our values to be being taken for the first for H, then for H plus H1 over there. I will have to calculate both of them at different values, what should be done over there. Then I will say here that I will have to add the two radii over there, that it is 3.4 R plus 1.7 multiply 10 is power 6, so that I can get for the first orbit to get its total addition should be done from 3.4 to 1.6. Then I will say here, let's go with it. Calculator, wait a second over here. Calculator. Okay. Here he said simply that 3.4 multiplies 7.1, 3.4 multiply plus 1.7 will give you this, will give you 5.1. So it is 5.1 multiplied 10 raised to power 6 is for H, height R plus H. So R plus H is equal to 5.1 multiplied 10 raised to power 6 should be being taken over there. After that, now he is saying it should be increased from R to H1. So then I will have to take the another potential height over there, where I will say here the values should be taken as um, now I will have to move from 1.7 to 6.8. Then my radius still remaining as it is, where I will say here that I will have to add my values with 6.8 plus plus 3.4 multiplied times power 6. So plus 3.4 multiply 10 raised to power 6 again. So let's go with it now to calculate this radius also. Then I will go for potential calculation of both of them separately, and then I will subtract both of them to get my final value of the mass to be shown by this value. So it is R plus H1 like that. This is being taken. So let's go with it. 6.8 plus 3.4. 6.8 plus 3.4 equals to this equals to 10.2. So it is 10.2 multiplied 10 raised to power 10.2 multiplied 10 raised to power 6 over there. Now I am using the formula of my energy to be stored in both of those cases. For that one, I will say here that we will take the potential energy. Potential energy or gravitational potential energy can be taken by its formula G M M into 1 over R1 square plus 1 over R2 square over there should be being taken over there. And square should not be there. Wait a second. For energy, for force, gravitational potential force, we take the value in the form of square. For energy, as we know that energy is F dot D over there, and F is G over R square, and one R is being cancelled, and energy is having this relationship over there, and it should be subtracted over there. All right, just put these values and arrange them and get the answer. Energy is 6.4 multiplied 10 raised to power 6 point 5.1 multiplied 10 raised to power 8. 5.1 multiplied 10 raised to power 8. 5.1 multiplied 10 raised to power 8. 6.67 multiplied 10 raised to power minus 11. Multiply m you want to calculate, and the mass of planet you are provided with 122 kg, 122 kg, and your values of R1 and R2. 1 over R1 is being taken as 5.1 multiplied 10 raised to power 6 minus 1 over 6.8 multiplied 10 raised to power 10.2 multiplied power 10 power point 2 multiplied 10 is power 6 being added. Okay. Now I am taking this inside of bracket first. Then I will get this value and then it will be divisible value over there. And then I will multiply this value on 5.1 multiplied 10 to the power 8 side. 6.67 is also down. 122 is also down. And what I will get, let's check over there. Let's go for, first of all, bracket start. Fraction introduced. 1 over 1 divided by 5.1 multiply 10 raised to power 6 there. After that, he is saying here minus, again fraction introduced, 1 divided by 10.2 multiply 10 to the power 6, 10.2 multiply 10 raised to power 6 over there, and then bracket close, and you have got this value. This multiply this value with 122, multiply 122, and also multiply this value with 6.67, multiply 10 raised to power minus 11. So this was the gravitational potential constant over there, gravitational constant value. So I get here 7.99 multiplied 10 raised to power minus 16. So it is 5.1 multiplied 10 raised to power 8 divided by m. I am making subject, and all of my that answer is coming down 7.798. 7.98 multiplied 10 to the power minus 16. 7.98 multiplied 10 raised to power minus 16. Let's introduce it in the form of our calculation here. Let's take it here. Okay. Okay, now what I will have to do, fraction introduced again. Fraction introduced. 5.1 multiply 10 raised to power 8. 10 raised to power 8 divided by 7.98. 7.98 multiply 10 raised to power minus 16. Multiply 10 raised to power minus 16 is equal to 6.3 multiply 10 raised to power 23. 6.39, so it is 6.4 multiply 10 raised to power 23 kg. And here he was saying us to show this value. So it is proved how to go with it. So remember that always that we will have to go for the relation of potential energy for the calculation of this concept behind it. After that, he is saying the gravitational potential at the surface of Mars and give your unit with your answer also. So potential formula, we know that it is Gm over R. So it is minus Gm over R, which will be taken as 6.67 multiplied 10 raised to the power minus 11 multiply 6.4 multiply 10 raised to the power 23 divided by, I should have to take the radius of Mars over there, 3.4 10 raised to the power 6. So it is 3.4 multiplied 10 raised to power 6. Let's go with it for calculation over there. So first of all, fraction introduced. 6.67 multiplied 10 raised to power minus 11. After that, multiply 6.4 multiply 10 raised to power 23 power 23 divided by 3.44 multiply 10 raised to power 6 over there. Wait a second. 10 raised to power 6 over there. So we will get the answer 1, 2, 3, 4, 5, 6, 7. So I will get here 1.3 1.3 multiply 10 raised to power 7, and this negative sign is giving the negative sign over there with its unit is joule per kg. Remember that when we defined the gravitational potential, we simply said work done per unit mass. So this is the unit for this joule per kg time over there. Let's move to the next part. I think so it is clear according to formulas implementation for this one. Okay, now he is saying here that he is moving, the satellite B is moved in the orbit in which the satellite remains in the same point above the surface of Mars. The orbit has a period of 25 hours. State what can be deduced from the about of rotation of the Mars on its axis. So simply we know that Mars will take 25 hours to rotate once on its axis. It means that Mars will rotate about its axis in 25 hours or less than it over there. Okay, state one other feature of this orbit over there. We can say here that orbit, what can I comment over there? Okay, sure. We will say that orbit is equatorial. Orbit is equatorial. Or we can say that it is the same direction as the direction of rotation of Mars will have been carried out. So for 1 mark, I'm simply saying that it is equatorial over there. Let's move to question number 2 there. Okay. Here he is saying a helium atom may be modeled as a nucleus surrounded by two electrons in diametrically opposite circular motion over there. One electron is going up and one is going downward. Okay. And it is, remember that it is a helium atom. Then we can say it is having two protons, two electrons, and two neutrons also over there. Helium particle in opposite, and each of radius 170 picometer over there. All right. State Coulomb's law. Coulomb's law, if I state in the mathematical formation, I will say that force of attraction or repulsion between two charges is directly proportional to product of their charges and inversely proportional to square of distance between their centers. And we can also say F is equal to K Q1 Q2 over R square. As I said, this is the Q1 charge and Q2 charge, and you are saying that it is both positive, then it is repulsive. If we say both negative, then there is attractive. If we say one positive, one negative, then it is attractive. In all of these cases, I have simply said to you the simple statement: the force of attraction or repulsion between two charges is directly proportional to magnitude of their charges, the product of their magnitudes of their charges, and inversely proportional to square of distance between their centers over there. This is called Coulomb's law. You can write it in the form of statement over there. After that, he is saying, state the charge on the nucleus in terms of elementary charge E. So that was helium having two protons and two electrons. So we will say here plus 2E will be the charge on the nucleus of the helium over there. Show that the electric force between the nucleus and the one of the electrons is 1.6 multiplied 10 raised to power minus 8 Newton. So electric force measured in newtons will be being taken into account. So I will say here, according to Ohm's law, I have to just put the values over there in the formula. F is equal to K Q1 Q2 over R square, and we can calculate this formula by using the relation. And if I observe that this is the charge with 2e, and then I will say I am doubling here this because of 2. After that, I am taking 2 proton and electron forces of attraction over there. Then I will say here K is having its value 9 multiplied 10 raised to power 9 as a Coulomb's constant. 1.6 multiplied 10 raised to power minus 19. I will have to take for 2 times. Then I will say I'm taking power 2 over here. After that, the separation between them is being taken as uh, separation between them should be being taken where it is written, wait a second, 170 picometer. 172 multiplied 10 is power minus 12, like pico is 10 is power minus 12. 170 multiply 10 raised to power minus 12, and this is r square, so I will have to take a square over there also. Let's go for its calculation. First of all, introduce the fraction over there. Fraction introduced. 2 multiply 9 multiply 10 to power 9. 9 multiply 10 raised to power 9 over there. Multiply, bracket start, 1.6 multiply 10 raised to power minus 1 9, bracket close, whole square. So this is the way the charge is done. Now come to downside over there. There is also being whole square, then take bracket over there. Then it is 170 multiplied 10 raised to power minus 12, it in the form of picometer. Then take the bracket close and take the square over there also. And you will get your value 1.5 multiplied 10 raised to power minus 1.59. If you just look 1.59 multiplied 10 to the power minus 8, 1.6 10 to the power minus 8. It is fine. 1.6 multiplied 10 raised to the power minus 8 Newton is the force over there to be shown in the form of complete working over there. After that, he is saying assume that the force is the only force uh, on the electron. Calculate the speed of orbiting electrons. Okay, here I am using for speed, I am using the formula of centripetal force. F is equal to mv square over r. I have this force value already calculated in the above question, that was 1.6 multiplied 10 to the power minus 8. So I'm taking here 1.6 multiplied 10 raised to the power minus 8 Newton divided by mass multiplied by radius. And if I go for multiplication of radius, then I remember that 170 multiplied 10 raised to the power minus 12 was the radius. And mass for electron is 9.1 multiply 10 raised to the power minus 31 kg. This constant mass of electron is already given in the insert table over there. So go for calculation of V square. It means I will have to take square root over here also, and by taking square root, I will get my speed over there. Just put these values into the calculator over there. First of all, square root, fraction introduced, 1.6 multiply 1.6 multiply 10 raised to power minus 8 multiply 170 multiply 10 raised to power minus 12, 10 raised to power minus 12 divided by 9.1 multiply 10 raised to power minus 31 kg. So I will get the answer, that is 1, 2, 3, 4, 5, 6. 1.7 multiply 10 raised to power 6 meter per second will be the speed of this. After that, he is saying calculate the period of orbit of the electron. So for this one, I will simply say here, use the formula of the speed, that is V is equal to 2 pi r for complete circumference of a orbit over there over time period t. Make the relation t as a subject. So it is 2 pi r over v. So 2 pi and r should be taken as 170 picometer again. 170 multiplied 10 raised to power minus 12 divided by V you have just calculated here, and that is having value 1.710 is power 6. So it is 1.7 multiplied 10 raised to power 6. Let's go with it and just simplify it. So I am saying here, first of all, fraction introduced. Then it is 2 pi multiply 170 multiply 10 raised to power minus 12 divided by 1.7 multiply 10 raised to power 6 equals to 6.2 multiply 10 raised to power minus 16. 6.2 multiply 10 raised to power minus 16 second will be your answer for this one. Okay. Here he is saying that in practice, the orbit of each electron is affected by presence of another electron. For the position of one electron, determine the ratio of electric field strength due to other electron and electric field strength due to nucleus over there. So I will have to go for ratio over there basically. Okay. Then because of electron and because of proton, then I will say here that the radius should be taken in the form of double when I am taking the nucleus, because that the nucleus is whole completely will be taken. And for the case of nucleus, I will have to take the simple, but for electric field strength of the other electron, I will have to take, let's watch how I am going with it. Electric field for electron 1.6 multiplied 10 raised to the power minus 19 divided by should be being taken as r square, but that r square should be taken with the help of complete nucleus 3.4 multiplied 10 raised to power minus 12. I'm using 340. 340. I'm just doubling the radius. 10 is for minus 12. This is for electron. And for the nucleus, I will have to put far down over there. Then my charge value should be being taken as also doubling, because nucleus is having 2 proton over there. Then it is 2 multiply 10 is to power 2 multiply 1.6 multiply 10 raised to power minus 19 also being taken with the radius that should be taken above over there, and that will be 1.7170 multiply 10 raised to power minus 12. So this is the relation. How should I have to go? Then I will say that it is being taken in the form of ratio. I know that this 1.6 10 is power minus 19, 1.6 10 minus 19 is gone. 170 will gone with the 2. 10 is power minus 12, 10 is power minus 12 gone. Minus 19 is gone over there. So I will have here the manly relation, because 10 is power minus 12, 170. When r square is taken and below it is 3.4 multiplied 10 power minus 12 is also being taken in the form of square to square root to cut over there. 1/7 and 1.7 is still pending over there in the form of 2 over there, and above is being taken. If I simplify this, I am getting the answer as 0.13. And remember that it is the ratio, so it has no unit over there. Just by putting all of these value, you will easily be able to cancel out all the effects of this factor over there. Use your answer D in 1. Suggest and explain how the orbit of electron is affected by the presence of other electron. So I will say here that resultant force will be slightly less than 1.6 times per minus 8 Newton, which was given in the previous section over there. So speed will be lower. So I will say here that the resultant force will be less, will be little less, or will be slightly less, will be little less than what was the value. Wait a second. The value for the force was having value in the form of 1.6 10 as per minus 8 Newton. 1.6 multiplied 10 is per minus 8 Newton. So I will say here that the speed will be lower, or speed will be smaller. Speed will be lower over there. I think so. The concept of this question is completely understood by you. Okay. Now he is saying specific latent heat. Specific latent heat is the amount of energy required per unit mass to change the state at constant temperature. Like I say here, amount of energy required, amount of heat required, amount of heat or energy required to change the state, even though I can take specific latent heat of vaporization or fusion for melting at its melting point like that, or I can say latent heat of fusion, latent heat of vaporization over there, change the state at its melting point or boiling point, amount of energy required to change the state at its boiling point of a body of an object of mass 1 kg. Means 1 kg mass of any object you have taken, and then at its melting point or boiling point, you are giving the energy to change the state over there. That is called specific latent heat of fusion or vaporization can be taken into over there. After that, he is saying explain why a substance specific latent heat of vaporization is usually greater than the specific latent of heat of fusion. Because I will say here, when I am taking latent heat of vaporization, then I will say here it involves, we can say, greater change in volume of substance, greater change in its volume at its boiling point over there of substance. And on the other end, we can also say that increased separation of molecules is available. Then I will say here more work will be done, and more work will be, more energy will be provided, more work will be done to change the set rate or to provide the energy. More work will be done to separate the molecules. I'm writing only the vaporization, and I will say here that you are understanding that the fusion is always showing the same behavior, but at lower rate over there. And remember that here kinetic molecular energy unchanged, so thermal energy needed, and molecular energy remains the same. Molecular energy of molecules, molecular energy remains the same over there, remains the same. So more heat is needed. So more heat is needed over there. So remember that why heat of vaporization is greater than heat of fusion over there, latent heat of vaporization. These were the reasons for this question over there. After that, he is saying an ice cube, of mass 37 gram at temperature 0 degree centigrade is placed in beaker containing water of 208 gram at temperature 26.4 degree centigrade. When all the ice has melted, all the water in the beaker has reached the thermal equilibrium at the final temperature 10.3 degrees centigrade. All right. Specific heat capacity of water is 4.18 joule per gram per degree centigrade. The beaker has negligible specific heat capacity, so it is perfectly insulated from the surrounding. All right. Determine the value of the specific latent heat of fusion of water. Okay, for this purpose, first of all, I will have to go for heat provided. Q is equal to mc delta theta. And then by getting my Q value over there, then I will put it Q is equal to ml over there. And the mass which was given will be being taken into account over there. For that purpose, I will say here, just simply go with the mc delta theta to add up over there, and change in temperature of water was from 26 degree, 26 point something it was, 26.4 degree, 26.4 degree, and now it is 10.3. So change in temperature is 10.3, and my change in temperature by subtracting both of them, 26.4 and 26.4 minus 10.3 is equal to this, is equal to 16.1 over there. So that change in temperature delta theta is equal to 16.1. So this is the way how to get the change in temperature. Now putting all of these values and adding both of them, then I will say here a mass of ice was 37 grams. So I'm taking also in gram, and m into L. Then I will say here that I should go for the whole value, where I will say that 37, the mass of ice multiplied by latent heat of fusion, plus 37 multiply 4.18 as mc delta theta, which I want to calculate. That was 10.3 over there, is equal to, this was the change temperature of the ice over available, like a in equilibrium for water over there. And now on the other end, I will have to go for mc delta theta for the water. So 208 multiply 4.18 multiply 16.1. So by making L as a subject, I will have to subtract all of this value on the right side, and then getting the L value over there, that will be 33335 joule per gram. Joule per gram can be taken as latent heat of vaporization over there, for latent heat of fusion for ice over there, for water over there, can be taken into account. Now he is saying state what is the meant of internal energy. So sum of all potential and kinetic energies, sum of all kinetic energies and potential energies inside the molecules of a liquid, of a fluid over there, can be taken into account. Sum of all potential and kinetic energies So total energy is of random motion of molecules. Total energy of random molecules should be taken into account for getting the total sum of internal energy should be being taken over there. Explain why the internal energy of an ideal gas is directly proportional to thermodynamic temperature of gas. So according to statements, I will say here that the potential energy in an ideal gas is zero. Potential energy in an ideal gas is always equal to zero over there, and so internal energy is of the gas is equal to the total we can say kinetic energy of the molecules. So I will say here if it is equal to zero, then total energy is equal to sum of all kinetic energies. Sum of all kinetic energies is equal to total energy of inside the molecules over there forever. And I can also say here that the kinetic energy of molecules is directly proportional to temperature because in ideal gas potential energy is zero. So I can say here kinetic energy is directly proportional to temperature of the body which is present inside the molecules of ideal gas over there. All right, let's move to the next part over here. What is he saying there that uh, a sample of an ideal gas, thermodynamic temperature T and internal energy U. All right, the gas is compressed, that the temperature is increased to 3T. Okay, three times temperature increased. During the compression, work W is done on the gas. All right, the gas is then cooled at constant volume so that the temperature decreases to 2T. All right, from T to 3T and 3T to 2T. Okay, shows in terms of all the WT and U work done gas on the gas, the thermal energy supplied to the gas and the increase in internal energy for each process is supplied. Okay, compression, cooling. Okay, this is only okay. Work done on the gas is positive in case of compression, and for cooling purpose, work done will be zero because in case of that, potential energy should not be being taken into account. Thermal energy supplied to gas. Then I simply said temperature is decreased to 2T from 3T over there. Then I will say that is directly proportional to each other. Then that is 2U minus W. And for cooling, I will have to take only the internal energy to be given out over there from the system. And for increase in internal energy, then it will be plus 2U to you in case of compression over there, and in cooling you will have to evolve the energy to the surrounding through this process. So then we can say internal energy should decrease in that case over there. Okay, let's move to the next question. I think so till here your every concept is clear now. Let's move to the next question. Here he is saying that a cuboidal block floats on liquid with the base of horizontal as shown. Liquid surface and height is taken. The base of the block is at the depth of h below of the surface. Okay. The block is displaced downward from a small distance and then released to oscillate. Shows the variation with h of acceleration. Okay. This is the graph for acceleration he has shown over there. Now he is saying that figure 3.1 shows the variation of kinetic energy over there. Now he is saying determine the amplitude of oscillation over there. So amplitude of oscillation. Amplitude of oscillation. So it is being taken as amplitude of the oscillation to be provided over there. Block H, block D over there, and he is showing some acceleration. Acceleration is directly proportional to displacement. Maximum is being shown over there. Determine the amplitude of the oscillation. When height is 1.3, then it is being taken as 1.8. So 1.3 and 5.8. If I take the ratio of both of them, then I will say here how much I will have to go for amplitude over there. Then it is zero point 0.5. It is coming this. So 1.5 is here, 1.5 is here in the form of H. So total is 3 over there, and it is 0 0.8 and 0 0.8 below also. So I will say here that we should go with the 0.18 to 1.4, 0.44 and to 6. So 0.60 will be the amplitude over there. That will be amplitude 0.60. After that, he is saying state what the line figure 5.2 shows about the nature of oscillation over there. So for how many marks it has given? Only for 1 mark over there, part 2 for that. We can simply say here that they are showing to and fro motion, all right. So it is, we can say oscillations are simple harmonic. Or oscillations are simple harmonic over there. Okay. Now he is saying state other three conclusions about the drawn from figure 5.2, 5.3 about the block and its oscillations. Use the space to show any working over there. So for that says, I will say here that the equilibrium position is at height. Equilibrium position is at height 1.4. 1.4 over there. And I can also say here that the total energy will be how much? Total energy will be how much? Then it will be approximately 5, 6, 7, 8, and 9. So we can say here that the total energy of oscillation is 9 joule. Total energy of oscillation is 9 joules. And after that, I can also say here that uh, the mass of block is given anywhere. No, mass is not given. Okay. So here I can say when we have to take this way, then we should go mass of block is 33 kg. Okay, mass of block is 33 kg. From the above relation we can find mass of block is placed at 2 I can say here mass of the block can be mass of the block is placed at 33 kg over there. So this was the simplified solution of this part. Let's move for the next part. Here he is saying that sketch the variation of H and potential energy of the oscillation. So as I said to you that you will get on H-axis and potential energy is zero, then we will say that from 0.8 meter from here to here, if I observe the above graph, then I will say here it will have its value to be shown in the form of EP over there. Then uh, H-axis, we can write it here that EP will be shown the minimum energy over there. Here it is having this range of the values to be being taken over there like this. Okay, in that case, I will say here that both endpoints of the curve are shown at the number 9 over there, little bit up, and it should also be written as the up voltage of EP as 9 joule over there. So this was your first 5 questions. In the next video, I will also upload the next 5 questions over there. Kindly subscribe my channel and see you in the next video with the next 5 questions. Thank you so much for today. Bye bye.